Okay, in this video I'm just going to go over how to add and subtract radical expressions and just show you a particular example that has an example of both adding and subtracting in the same line, okay? So let's go ahead and start. So here's our problem. I have 6 radical 50 minus 2 radical 8 plus 5 radical 12. And you'll remember that you treat each of these radicals like they were their own individual variable, right? And you know from previous experience that you cannot add and subtract different variables. So your task here is to see if you can change each one of these or simplify each one of these radicals so that they become the same. Once you've done that, then you can add or subtract the coefficient in the front. All right. Another way of looking at this is like saying I have 6 radical 50s. I'm going to subtract 2 radical 8s, and I want to add then 5 radical 12s. And again, you notice by saying it that way, you see that it has to be the same kind of a radical in order to actually add or subtract them. So, as I'm fond of saying, difficult problems are really just a series of individual, smaller, simpler problems, right? So let's just go ahead and look at this problem first, 6 radical 50, and see if we can simplify it into a slightly different form. Let's simplify it all the way, as far as we can go, okay? So I look into the radical and I see it's 50. I know that I can rewrite that 50 as 6 radical 25 times 2. Now, why did I choose those two factors? Because 25 happens to be a perfect square, and I know that the square root of 25 is just 5. All right, so let me just go ahead and continue to simplify that. Now remember, when you take the square root of 25 and make it 5, it can go outside the radical now. And now the square root of 2 just remains as the square root of 2. And I can multiply now the numbers outside the radical and get 30 radical 2. Okay? So now it looks like 60 radical 50 is the same thing as saying 30 radical 2. Let's see if I can change either one of these to a radical 2. Now, I look at 2 radical 8, and again I see that radical 8 can be rewritten as radical 4 times radical 2. And again, I chose 4 and 2 because 4 is a perfect square, and it will easily change to the square root of 4 is 2, so I'll put it back outside, and then that stays as radical 2 underneath. And again, just like over here, you can multiply the two outside whole numbers, and now I have 4 radical 2, and look at that. Now I'm starting to get similar or like radicals. Let's see if I can do the same thing with this 5 radical 12. Again, I know that I can rewrite 12 as the square root of 4 times 3. Okay? And again, I chose that because there's a perfect square. So I'm going to put that outside here. Radical 3 stays as radical 3. Again, multiply the two outside numbers. They're whole numbers, and I get 10, and the radical 3 stays. So now let's look. Looks like I have 30 radical 2 minus 4 radical 2. Those can be subtracted, but then I have to add 10 radical 3, which is like a different radical. Can't do anything with that one. My final answer, therefore, or my final simplification will be 30 radical 2 minus 4 radical 2, and I'll get 26 radical 2, and then I'm just going to add 10 radical 3's outside it. And that's my final simplification. I hope that was helpful.